Okay, we just finished question number 40, at least I believe we did. Yeah, I think we did 40. And now we're going to go into this over here where it says two steps, x term and numbers on both sides. All right, so let's take a look. And the first question I'm seeing over here, 41, I'm going to do the whiteboard to do it. And let me just take a look at that. And I think we just did 40, right? Kind of scrolling through this. Yeah, so now we're on 41. Put this on the side, 41. And looking at 41, I see 8x minus 18 equals 10x minus 20. All right, so what I'm going to do over here, I'm going to subtract 8x from both sides. I want to get x onto one side, and I'm going to add 20 to both sides. Now, I consider that two steps, by the way. But let's go through it. What do you get on the left side? You get 2. What do you get on the right side? You get 2x. All right, now what I'm going to do is divide both sides by 2, and you get 1. X equals 1. You know, I'm going to check it. I check it in the original. It's 8 minus 18 equals 10 minus 20. 8 minus 18 is minus 10, and 10 minus 20 is minus 10. All right, let's go to 41. I'm sorry, 42. And let's write that down. And 42 is 12 plus 8x. This is 42, right? 18x plus 12. All right, so I've got that right. 12 plus 8x, 18x plus 12. Well, first I'm going to do is subtract 8x from both sides, and I'm going to subtract 12 from both sides. What do you get? 0 equals 10x. All right? What I'm going to do now, divide both sides by 10, and you get x is equal to 0. As you know, I'm going to check it in the original. That's going to be 12, and 8 times 0 is just 0. On the right side, 18 times 0 is 0, and you get 12. Works out pretty nicely. Let's go to 43. And 43 is 12 plus 18x. Problems really do look remarkably the same, don't they? Now, something I really haven't mentioned much, but not all equations can be made to be true. I should say not all equations can be made to be true. Some they're conditionally true. Sometimes they can never be made to true. Let's go through it, though. What do? Subtract 18x from both sides. And subtract 9 from both sides. And what do you get over there? Well, let's take a look at it. You get 3 equals 0. This was known as a contradiction. So I'm going to say there's no solution to the problem. That might take some time and effort to think about it, but it's a contradiction. There's no solution to the problem. All right, let's go to 44. And let's take a look at 44. 44 is 12 plus 18x equals 18x plus 12. Well, same thing. Subtract 18x from both sides and subtract 12 from both sides. And what do you get over there? 0 equals 0. This is what's known as an identity. This is always true. Always true. It's true for all x, by the way. Always true. All right? Again, most equations that we did prior over here were conditionally true. There's a condition on the truth. What was that going to be? What we found. Every time we found a condition that made us true. Over here, we could not find a condition that made us true, so we just simply said there's never a condition that makes true. We said no such problem. This one over here is any x would work, by the way. Any x in the universe will work. All right, let's go to 44. I'm sorry, 45. And 45 is 1/5. Whoops, sorry about that. I don't know what happens there, but I guess I touched something. Seems like I lost a lot of stuff there too, didn't I? Let me just shrink that down, see what happened. Yeah, I guess I did. Anyway, let's go to the next one. And I believe we just completed 44, so let's go to 45. Let's blow this up. What's 45? It's 1/5 of an x, and then plus 10 equals 8 minus 1/2 of an x. I'm going to do something different now. I'm going to do something that a lot of teachers do recommend, and what they recommend is to multiply both sides by the LCD. Well, the LCD is 10. So I'm going to multiply the left side by 10 and the right side by 10. So 10 times the first term is 2x. 10 times 10 is 100. 10 times 8 is 80. And 10 times 1/2 is going to be 5. All right, what did I accomplish with the fraction? What I'm going to do now, add 5x to both sides and subtract 100 from both sides. What do you get there? 7x equals, well, it's going to give you minus 20. All right? And what do you get now? We can divide both sides by 7. And what do you get? X equals minus 20 over 7. Put a box in that. I do want to check it, by the way. And certainly, you're free not to check it. You say it's just exhausted, whatever. So 1/5 minus 20. I'm looking at the original equation, by the way. And then plus 10 equals 8 minus 1/2 times minus 20 over 7. Let's see if we can get through that. And the first thing I'm noticing, the first term reduces to minus 4/7. I'm going to write 10 as 70 over 7. That's the same thing as 10. I'm going to write 8 as 56 over 7. And then I'm going to do this one over here. This is going to be plus 10 over 7. That's a 20, by the way. All right, what do you get there? 66 sevenths. And what do you get over here? 66 sevenths. It does check out, right? Let's go to 46 now. And 46, I turn the computer back on, look what the number is. 5/4 of an x plus 3 equals minus 2 minus 1/2 of an x, right? So let's say make sure I copied right. 5/4 of an x plus 3 equals minus 2. Yeah, I think I did okay. I'm still going to do something I did prior. And it worked for some students. Maybe it doesn't work for you. Try what you like. But the LCD is 4. Multiply both sides by 4. Relatively simple. You get 5x, 12, minus 8, minus 2x. What I'm going to do now, I'm going to add 2x to both sides. And I'm going to subtract 12 from both sides. What do you get? 7x. And then what do you get over there? You get minus 20. All right? What do you get here? X equals minus 20 over 7. Did I just do that? 45 and 46, are they the same questions? No, they're not the same question, but sure, they got the same answer, didn't they? Let's take a look at that. And I'll go back to the original one, which is, again, this is number 46. Let me look at it. It's 5/4. I'll write this down for you. We're going to check it. Minus 20 over 7. And then plus 3 equals minus 2 minus 1/2 times minus 20 over 7. Let's just check it and see what happens. I'm looking at this over here. What do I say? Well, 4 goes into minus 20 minus 5 times. So I get minus 25 sevenths. Plus, well, 3 in terms of sevenths is going to be 21 sevenths. Minus 14 sevenths. Over here you get what? Plus 10 sevenths. What do you get there? Let's see. That would give you minus 4 sevenths. And what do you get here? Minus 4 sevenths. All right? We got the right answer. All right? Let's keep going. It's 46 out of 47. That's a conditionally true statement. Let's put this one down, which is 1 minus 3/4 of an x equals 1/8 of an x minus 13. Got to make sure I'm copying things right. 1 minus 3/4 of an x, 1/8 of an x minus 13. Again, I can multiply both sides by the LCD. The LCD is 8. Multiply this side by 8, that side by 8. What do you get? 8 minus, well, 4 goes into 2 times. 2 times 3 is 6. You get x. Then you get minus, well, 8 times 13 is 80 and 24, so 104. I'm going to add 6x to both sides. And I'm going to add 104 to both sides. What do you get? 1, 1, 2 on the left side. We get the right side, 7x. All right. All right, let's do this now. I'm going to divide both sides by 7. Any more involved problems? There's no doubt about it. Let's see, 112 divided by 7. 1, that's 7, right? And what are you going to get there? Well, 42. Then you get 16. So what's x? X is 16. Let's check it, though, in the original. So it's going to be 1 minus 3/4 times 16 equals 1/8 times 16 minus 13. We're checking it. What do you get? 1 minus, well, 4 goes into 16 4 times, and 4 times 3 is 12. What do you get here? 8 goes into 16 2 times, and let's see if this is true. 1 minus 12 is minus 11, and 2 minus 13 is also minus 11. Worked beautifully. All right, we're going to get a 48 now. And again, these are more involved questions. There's no doubt about it. So 3x, let's see, plus, what number? Oh, 48, right? Okay, let me take a look. 3x plus 1/2 of an x, oh, I'm sorry, 1/2, sorry about that, equals 3/4 minus x. It's easy to copy something down wrong, by the way. So I'm going to do the same thing I did before. I multiply both sides with the LCD, which is going to be 4. You get 12x plus 2 equals 3 minus 4x. I'm going to add 4x to both sides. I can subtract 2 from both sides. What do you get there? 16x equals 1. What's x? Well, you divide both sides by 16 now. And what do you get? 1/16. I'm going to check it. Let's write this down. 3 times 1/16 plus 1/2 equals 3/4 minus 1/16. What do you get there? Well, you get 3/16. Let's see, that would be 8/16, same thing as 1/2. 3/4 in terms of sixteenths would be 12/16 minus 1/16. 3 plus 8 is 11/16, and 12 minus 1 is 11/16. This worked out beautifully. Let's go to 49. And again, these are more involved questions, there's no doubt about it. So 49 is minus 9 minus 1/3 x is equal to, and that's going to be 2x plus 5. I'm going to multiply both sides by 3. You get minus 27 minus x equals 6x plus 15. I'm going to add x to both sides, and I can subtract 15 from both sides. What do you get there? Let's see, 37, 42, minus 42. What do you get over here? 7x. Divide both sides by 7, and you get x is minus 6. Still going to check it. Minus 9 minus 1/3 times minus 6 equals 2 times minus 6 plus 5. What do you get? Minus 9. And what is going to get? Plus 2 over here. Again, 6 divided by 3 2 times, negative, negative, positive. Minus 12 plus 5. Well, minus 9 plus 2 is minus 7, and minus 12 plus 5 is also minus 7. It works very nicely. Let's go to 50. And what's 50? Again, it's a more involved question. 1/3 plus 4x is equal to 7x minus 2/9. I'm going to do the same thing I did before, multiply both sides by the LCD, and the LCD is 9. What do you get? 3 plus 36x, 7 times 9 is 63, minus 2. What would I do here? I would subtract 36x from both sides, and I would add 2 to both sides. What do you get there? 5. And on this side, what do you get? Well, let's see, 36 to 63, that's going to be 27. Let me just check that. 50, 57, yeah, 63. What do you do? Divide both sides by 27. What do you get? X equals 5 over 27. All right, I'm going to check it, and I know it's painful, but we're going to check this. So it's 1/3 plus 4 times that number, which is 20 over 27. What's 7 times 5 is 35 over 27 minus 2/9. All right, whoops, 2/9, sorry about that. All right, common denominator, 27. What times 3 is 27? 9. So you get 9 plus 20, which is 29. 27, right? What do you get there? 35 minus, be careful about this. What times 9 is 27? 3. 3 times 2 is 6. It worked out nicely because 35 minus 6 is 29. All right, let's go to the next question. We're on 51 now. And 51 is a decimal number. All right, 0.7 minus 2.4. And then 5.3. And then plus 0.3. I'm going to multiply both sides by 10. What do you get? 7x minus 24 equals 53 plus 3x. I'm going to subtract 3x from both sides. And I'm going to add 24 to both sides. What do you get? 4x equals 77. All right. What I'm going to do now, well, I'm going to divide both sides by 4. And what do you get? X equals 77 quarters. All right, I'm going to write this down a little differently because they spoke in decimals. I should speak in decimals. So let's put this over here. 1, that's 4. You get 3, 7. Let's see, that's 9. That's 36. What do you get there? 1. You get a 0. I'll put a 2 over there. 2 times 4 is 8. Subtract to get 2. Then 5. 19.25. All right. I hate to do it to you. I'm going to check it. So it says, where do you check it in the original expression? Let's write this down. 0.7, and yes, you're free to use calculators. 19.25 minus 2.4. Whoops, that's not good. I'll tell you why it's not good. You write something down you're checking, and you're writing down something that's not correct. It's not going to check, right? Will not check. All right, so I'm going to erase this over here, go back to my pen, and it's 2.4 equals 5.3 plus 0.3 times 19.25. All right. Now, granted, I do know it's difficult, and I realize sometimes I just need to use a calculator, and I'm not opposed to it. Use the calculator. All right. I'm going to try to do this in a peaceful way, though. I'm going to do the right side first, 5.3. And then I'm going to do this, use 0.3 times 19.25. Let me write that down for you. Let's do that. 3 times 5 is 15. 3 times 2 is 6. 6 plus 1 is 7. Let's see. 3 times 9 is 27. And 3 times 1 is 3, and 3 plus 2 is 5. So what do you get there? You're going to get 5.775. All right, let me get my eraser out and erase some of that arithmetic now. All right. Let's hope you didn't make a mistake, right? I'm going to add those two numbers together, and I'll put this on the side for you. You know what I'm going to do? I'm going to put it, I'm going to continue to erase things that I don't want to see anymore. Like I really don't want to see the arithmetic. And let's write this down. So 5.775 and then 5.3. That's 0, 0. 5, 7, that's 10. And then you get 11. So 11.075. All right, here comes the tough part. Let's do it now. And I'm going to do 0.7 times 19.25. Let's see, 7 times 5 is 35. That's not so bad, right? 14 and 3 is 17. 63, 64. 7 and 6 is 13. All right, so what do you get over here? You're going to get 13.475 minus 2.4. All right, let's go to town. So you get 13.475 minus 2.400. 57011. Wow, we got it. We're doing all right. Let's go to the next question. That's 51. Let's go to 52. And you see these problems are more involved, by the way. All right, I might get tired too and not do the checking. So we're on 52 now. And what do you get? 3x minus 8.25 equals minus 10 plus 7x. Well, what I'm going to do over here is I'm going to subtract 3x from both sides. I'm going to add 10 to both sides. What do you get there? We get 1.75. And then on the right side, you get 4x. All right? Then I got to divide both sides by 4. And they were speaking in decimals. I should continue to speak in decimals, by the way. All right, so I'm going to say, let's see, 4. 4 times 4 is 16. Then I get 1, 5. I'm going to say 3. 3 times 4 is 12. And then I get 3. Let's see, 7. That's 28. And then I get 2. And that looks pretty easy. That's 5. So what do I get? I get x equals 0.4375. All right, I hate to do it to you, but you know I'm going to check this guy. All right? So the first thing I'm going to do is I want to do 3 times that number. I'm checking it in the original. This is the original. 3 times that number. Well, it's going to be 15, 21, 22. Let's see, 9, 10, 11. 3 times 4 is 12, 13. So you're going to get 1.3125. Let's see if I did that right. 4, yeah, I did okay. Minus 8.25 equals minus 10. Let me get my eraser out again, erase some of this business over here. I really don't need to see the arithmetic, by the way. But I do need to do 7 times that number, all right? So 7 times that number, which is 0.4375. You get 35. 7 times 7 is 49. So you get 52. 21, 26. 28, 30. So what do you get there? Let's see if I did that right. Yeah, I did okay. So it's going to be plus 3.0625. Wow. This looks tough. So I'm going to write it down for you. I know it's tough. Right, so I'm going to write down 10.0000 and then minus 3.0625. All right, I know this is problematic, by the way, but you know I'm going to be borrowing things, and this is always like, can I really do that? Of course you can, all right? So if I were doing that, you realize that, you know, in the end I'd have a 10 there, so I'd put a 5 down. Now, the other one, before that I had a 10, but now it's a 9, so this is 7. And before that, there was a 9 there as well, so it's 3. And then I got what there? Let's take a look at that. What I mean by borrowing, I'm saying this is 0, this becomes 10, this becomes 9, that becomes 10, this becomes 10, 9, 10. I hate to write those things down for you, by the way, but you could. You know, so 5 from 10 is 5, 2 from 9 is 7, 6 from 9 is 3, 0 from 9 is 9, and 3 from 9 is 6. Wow, that's a crazy looking number. 6.9. That, by the way, I'm not saying that's the right answer yet. I just did my arithmetic over here. It's actually negative. Let's do the other thing, a little more complicated, but it's 1.3125, and I'm going to be subtracting 8.25. So I'm actually going to subtract it, but I know it's a negative number, by the way. So 8.2500. All right? So I'm going to do the same thing. This will become a 4. This becomes 10. Borrow from that, that's a 9. That's a 10. 5 from 10 is 5. 2 from 9 is 7. 1 from 4 is 3. Wow, I got 2 there, don't I? So this is going to be 7. And this will be 12. And that gives me 9. 1 from 7, 6. What do you get? Minus 6.9375. We're getting the same thing? We're getting the same thing. We got a good answer over here. Again, checking is probably the worst thing we have to do. Let's go to 53. And what's 53? All I can do is read it to you. And again, it's more decimals, so it's 4.5. plus 2.4, 3.5, and then minus 10. Well, let's take a look at it. Doesn't look that bad. Minus 3.5x and minus 2.4. What do you get there? 1x. I'm not going to write the 1 down. You get x, right, equals minus 12.4. I think you know by now I'm going to check it. And again, it might seem pointless, but let's write this down. 4.5 minus 12.4 plus 2.4 equals 3.5 minus 12.4 minus 10. All right? Let's go through it. Again, it's problematic to check. It really is. And say I'm exhausted. I want to do a calculator. Do the calculator then. So I'm going to write this over here as 12.4 and 4.5. Do the multiplication. 5 times 4 is 20. You can carry the 2 if you want. 5 times 2 is 10. 10 plus 2 is 12. 5 times 1 is 5. And 5 plus 1 is 6. Let me get my eraser out to get rid of the carries. Let me go into the next number, which is 4. 4 times 4 is 16. 4 times 2 is 8. 8 plus 1 is 9. And 4 times 1 is 4. So add those numbers together. Let's count the decimal places. So I get 55.80, but it's a negative number, plus 2.4. I get my eraser out, get rid of my arithmetic, and I'm going to do more arithmetic here. And I'm going to do 55.8 minus 2.4. 0, 4, 3, 53.40. So minus 53.40. We're not done yet. We've got to do the other side now. Get my eraser out and write it down. And what do you get? 12.4 and 3.5. 5 times 4 is 20. 5 times 2 is 10, 12. 5, 6. I get my eraser out. Eraser's above it. Let's move on. 12, 6, 7, and 3. 0, 4, 13, 4. 2 places, 43.40. Minus 10. Add those two numbers together, you get minus 53.40. It's working out as advertised, by the way. Let's go to 54. And all I'll do is look at it. Again, I think checking probably takes the most amount of time, by the way. So I think we're on 54, right? Now it's 53. Yeah, 54. And what's 54? It's minus 23 plus 1.8 equals 1.5. And then minus 23. Well, what I'm going to do over here is I'm going to subtract 1.5x from both sides. And I'm going to add 23 to both sides. And what do you get? Well, you're going to get 0.3x equals 0. Divide both sides by 0.3. And this is nice. What do you get? You get x equals 0. Can I check that? Yeah, pretty easily. Check in the original. You get minus 23 equals minus 23. It checks out beautifully. Also very easy to check. Let's go to 55. What's 55? Getting a little bit simpler now, aren't they? 3x minus 25 equals 4x plus 9. Well, I'm going to subtract 3x from both sides. And I'm going to subtract 9 from both sides. And what do you get over here? Well, you get x. On the other side, what do you get? You get minus 34. So x is minus 34. Let's just check it. So it's 3 times minus 34 minus 25 equals 4 times minus 34 plus 9. Looks a little bit easier to do. Gives you minus 90 and 12, minus 102, minus 25. This is going to give you, let's see, minus 120 and, 120 and 16, 136. Minus 136 plus 9. What do you get over here? Minus 127. What do you get over here? Minus, 127. We did fine. Let's go to the next one, which is 56. And 56 is minus 3x plus 27 equals 18 minus 8x. I'm going to add 8x to both sides and subtract 27 from both sides. What do you get there? You get 5x. And then what do you get there? You're going to get minus 9. What's x going to be equal to? Minus 9 fifths. All right, I'd leave the answer that way. If you prefer the decimal, by the way, it's going to be minus 1.8. If you prefer a mixed number, which I think would be a bad idea, it's going to be minus 1, and you're going to get 4 fifths. All right, also a good looking answer. I like this answer the best. I'm going to check it now. And it's going to be minus 3 minus 9 fifths plus 27 equals 18 minus 8 times minus 9 fifths. What do you get here? 27 fifths plus 27 equals 18 plus 8 times 9 is 72 fifths. All right, let's check it out. Column denominator is 5. This is 27 plus, well, 5 times 27 is 135. This is 5. Let's see, 5 times 18 is 50 and 40 is 90 plus 72. Let's check this out. What do you get over here? Let's see, 135, 140, 160. I think I made a mistake. And I'm glad I made a mistake, because it really says, if I'm not getting an agreeable answer over here, and I see my mistake now, and I want to point out what the mistake was. Someone says, I don't even see it. It's right over here. I'm just checking it too. That was 27 fifths, by the way. 27 and 135 is 162 over 5. And what do you get over here? 162 over 5. It checks out nicely. That was number 56. Let's go to 57. We're near our break, by the way. Now let's proceed forward. I know this is very difficult, by the way. You get 8x plus 8 equals 10x plus 10. I'm going to subtract 8x from both sides, and I'm going to subtract 10 from both sides. What do you get? Minus 2. Over here you get 2x. Divide both sides by 2. You can get x is minus 1. I'm still going to check it in the original. You can get minus 8 plus 8 equals minus 10 plus 10, and that certainly does stand to reason. Let's go to 58, I mean. What's 58? Oh, a bunch of fractions. 1/2 of an x plus 1/2 equals 1/3 of an x plus 1/3. All right? So I would recommend, again, multiply both sides by the LCD. What's the LCD? Is 6. 6 is the LCD. 6 times that side, 6 times this side. You get 3x plus 3 equals 2x plus 2. Subtract 2x from both sides and subtract 3 from both sides. What do you get? X equals minus 1. Let's check it. What are you going to get? Minus 1/2, and the original, by the way, plus 1/2 is identical to minus 1/3 plus 1/3. Yep, and it stands to reason. Let's go to 59. And what's 59? Big numbers, right? So minus 201 plus 26x equals 30x plus 189. All right, I would subtract 26x from both sides, and I would subtract 189 from both sides. What do you get over here? Let's see. You can get minus 390. And then the other side, what are you going to get? 4x. All right, not so bad. So I'm going to divide 4 into 390 now. What do you get over there? Actually, you know what? I'm not going to do that. I'll just write that as minus 390 over 4 is equal to x. And I want to be consistent. I don't want to write decimals down unless I spoke decimals. I'm just going to divide by 2. So 2 goes into 390. I'll write that down for you. That's 1. That's a 2. 1, 9. That's 9. That's 18. And then you get 1, 0, which is 5. So 195. Whoops. Over 2. So x equals minus 195 over 2. I don't want to use a decimal, by the way. So could I check it? Let's just check it. Minus 201 plus 26 times minus 195 over 2 equals 30 times minus 195 over 2 plus 189. Yes, I know it's difficult to check. I just want to go through it for you. So minus 201 plus, well, 2 goes into 26 13 times. And what do you get over here? 2 goes into 30 15 times. And I realized from looking at this, do I really need to check that? Not really, but I'd like to make sure whatever I'm saying is correct, by the way. So I'm going to do 13 times 195 now. 3 times 5 is 15. That's not bad. 3 times 7 is 27. 27 plus 1 is 28. 3 times 2 is 3. 3 plus 2 is 5. And then the 1 times 195 is pretty easy. What do you get there? 5. Over here, you're going to get 13. And then you can get 15, 2535. So minus 201 minus 2535. I'm going to add those two numbers together. 2535, 201. You get 6372. 2736. All right, let's go to this side. Let me get my eraser. I get rid of my arithmetic. I really don't need that arithmetic anymore. But I want to do the arithmetic on the other side. And that's going to be 15 times 195. Yes, I know it's negative. What do you get there? 5 times 5 is 25. 5 times 9 is 45, plus 2 is 47. Then you get 5 and 4 is 9. And then 10 times 195 is pretty simple, right? 5, 9, 1. 5, that's 12, that's 19, 2, 2925. Plus 189. All right, let's do that. So it's 2925 minus 189. All right, borrow from the 2, that becomes 1. This is 15, that's 6. Borrow from the 9, that becomes 8. This is 11. Let's see, you get 3. That looks pretty good. 1 from 8 is 7, and you get 2. So what do you get over here? Minus 2736. We're doing good. Things are working out as advertised. Let's go to 60 and take a break. Turn the computer back on so I can see the actual problem. And this is 9x plus 3/5 equals 2 plus 4x. Again, my recommendation, get rid of the fraction. LCD is 5. It's only one fraction, by the way. 45x plus 3, 10 plus 20x. I'm going to subtract 20x from both sides. And I'm going to subtract 3 from both sides. What do you get there? 15x equals 7. X equals 7/15. All right, let's check it. Where do you check it? In the original. So you get 9 times 7/15 plus 3/5 equals 2 plus 4 times 7/15. All right, let's do it. And to do that means I'm going to do some arithmetic over here. And the first thing I notice is the 9 and the 15 have a 3 in common. 3 times 7 is 21. And 3/5. And that's 24/5. Let's go to this side. And looking at that, I'm looking at that, and let's take a look. And I'm going to say common there is 15 there. You get 30 plus 28. And 30 and 28 is going to be 58. And I think I made a mistake. Let's take a look. And I'm glad I made a mistake. Either somewhere, take a look what I did. And I got 45x plus 3. That looks pretty reasonable. 10 plus 20. I subtracted 3, subtracted 20. And I got, let's see, I see it now. 20 from 45 is not 15. It's 20. All right? So I'm glad I checked it. This was an exam question. I would just simply cross this stuff out. That's not true. It led to a false statement. I knew that when I got towards the bottom of it. And this is a false statement too. Let's write this down now. So what's x going to be equal to? 7 over 25. I'm still going to check it, see if I'm right. So it's 9 times 7 over 25 plus 3/5 equals 2 plus 4 times 7 over 25. Let's go through it. And you get 63. 25ths, plus, I want to make this into 25ths, multiply top and bottom by 5. I want to make the 2 in terms of 25ths. That's going to be 50 25ths. And 7 times 4 is 28. 63 and 15 is going to be 78 25ths. 50 and 28 is 78 25ths. So there's a point to checking to make sure you're getting the right answer. That was number 60. We'll take a break and we'll come back. Thank you.